seventh video in our series of videos on basic nozzle knowledge, and this covers air atomizing nozzles. So up till now we've just looked at hydraulic nozzles with a single fluid feed. This video quickly looks at the effects of adding air into the nozzle. The basic working principle of an air atomizing nozzle is we no longer have a single feed into the nozzle, we introduce air in there as well as the liquid we're looking to spray, and this air creates a fast moving airflow that entrains the spray in it and atomizes the spray and can also shape the spray. It changes things up quite dramatically in terms of the basic spray properties. So what effects does this have? Well, firstly, droplet size. Air atomizers will tend to produce much smaller droplets than other spray nozzles. You can get somewhere close to them if you work at very, very high pressures with hydraulic nozzles, but air atomizers are a really good way of getting very small drop sizes at relatively low fluid pressures. So the drop size is no longer actually dictated by the fluid pressure. If you remember back to some of the equations we looked at, in order to get very small drop sizes, you're actually going to have to get very, very high pressures with hydraulic nozzles. This isn't the case with air atomizing nozzles, because the primary factor is the amount of air that you put in there and the air pressure you put in there, and this is what dictates the droplet size. Air pressure is the primary factor in atomization and droplet size. The second big factor that's affected is the spray pattern. With air atomizing nozzles we can get variable patterns depending on the air fluid mix, and with most hydraulic nozzles the spray pattern is relatively stable and it varies a little bit with the pressure in some nozzles. For air atomizing nozzles we can actually generate a great variation of spray angles and spray patterns from a single nozzle depending on the air fluid mix. Now some designs even have a separate air feed for the shaping of the actual spray, so this air is purely there to actually shape the spray, dictate the spray angle, so we can vary that, and that's an independent air feed from the atomizing air feed, which is used to control the droplet size, so you get a great degree of control. So we've got this second variable to play with, the air. The third big effect of air is it has a massive effect on impact and reach. Now although the velocity of the drops is actually increased quite dramatically because they're entrained in this fast moving airflow and will maintain a velocity quite a lot further from the nozzle, because they're so finely atomized we don't actually have much of an effect on impact. We wouldn't use air atomizers in any kind of application that requires impact. It doesn't really have a positive effect on impact per se, because any of the gains made are kind of lost by the atomization effect. However, it does have a very big effect on reach. Now in this videos here you can see a misting nozzle and an air atomizing nozzle spraying side by side. What you can notice here is that the misting nozzle rapidly loses its coherence, only forms a coherent spray pattern very close to the nozzle. The air atomizing nozzle holds its spray pattern an awful lot longer before it kind of descends into a fog. This can be used to project sprays quite big distances. So for applications like dust control, where we're looking to distribute a fine spray over an area, air atomizers are really great for that, because the air carries that fine mist around an area. And also for things like coating applications, if we've got air currents moving around in the factory and we're spraying a very finely atomized coating spray, it's possible with a hydraulic nozzle, even at quite close to the target, that could kind of get wafted off target a bit. Air atomizers have that entrainment within the air, so they help to keep things like that on target. The final effect of air atomizers is on liquid distribution within the spray pattern. Because we are mixing it up with air and because we're finely atomizing it due to the air, we tend to not get some of that separation of fluid density based on drop size. With hydraulic nozzles, centrifugal effects, things like that will actually tend to naturally separate out some of the big drops and smaller droplets, so we get those variations in the spray pattern. Depending on the nozzle design, this can be a bigger or greater variation. But with air atomizers, we tend to get a more even distribution because it's not purely on the weight of the drop and then centrifugal type forces that cause those local variations. We get a more even pattern as well. That's our very basic video on the effect of air atomizers. It's quite a complicated topic. It's quite a complex interplay between the air and the fluid mix. So if you've got any more questions on that, please do give us a call or consult some of our other technical articles on this.